Hey everyone, hope everybody's doing well. So now that you have R in RStudio installed, let's walk through some of the fundamentals. So when you first open RStudio, you'll always see three panes, like you can see on my screen here. The console pane is the largest pane that I have up here, and this is the primary place where you're going to interact with R when you're developing code and using R and RStudio to solve problems. The environment pane is up here on our upper right side, and it has a few different things going on, but environment and history are two tabs that really do come in handy. The environment tab will show the data, objects, and variables in the current R session, and then the history tab will provide a list of all of the console commands as we use them. So here you can see a bunch of commands that I most recently used to create a couple different models. And then this broom function will actually clear these objects from the workspace. So given that I'm not working with these items anymore, I can click on the broom. It'll ask me if I want to clear all my history entries. I sure do. Boom, it's gone. And now I've cleaned things up, so I'm ready to work on whatever it is I'm going to work on today. And then the help pane down here has a number of different functions. You can explore files in your default working directory. You can look at different plots if you create them in R. You can see a list of all the packages that you have installed, and you can also get access to all of the different documentation and help files. So here it looks like recently I was looking at the formatting and usage of something called a Hux table, which we may or may not get to in this class. And then there's occasionally a fourth pane that you'll see, and that's the source pane. And this is where you can write your own scripts. Or if you open an R or RMD file, it'll open in the source tab. And if you want to save code that you've developed, you can create a new R or RMD file, then enter your code into the source pane. And when you finish putting in the code you want to save, you can save that file, and you can reopen it and return to that code anytime. And in fact, one thing I definitely suggest is to have an R file where you keep examples of code that seem like they might be helpful. For example, an example of the code to import an Excel file, or an example of the code to run a multiple linear regression model. So how we would go about creating one of these new files, we'd go into File, New File, and then there's a number of different types of files we can create. R script is just called an R file. The file extension is .r. But then we can also create other types of files as well. The other primary type of file that I'll reference fairly often is an R Markdown file. And then there are some other options that if we touch on them, I'll explain them at that point. But if you want to just create a file where you can save your script, an R script file will do the trick. So I'll open that, and it's created sort of a canvas for me to type in code that I can work with. I can run it. I can also save it and reopen it later and use the code again. So that's really one of the biggest assets of being able to create and use these R or R Markdown files, is that we can come back to them and we can reuse the code over and over and over again. So this is a data analytics class, so we're going to look at data. Most of the time we're going to import data sets, and we'll get there in a second, but we can also manually input data, and I wanted to take a moment just to kind of show you how that works. So say that I want to calculate the mean of a set of 6 numbers, maybe -4, 0, 6, 1, -3, and -4. To do this, we can use the C function, which combines, C is the first letter in combine, these values into a single list, or more specifically, a vector. And we can label this data as example _1. So I'm going to enter in this code. Example _1, that's what I want to name this list or vector. And then I type in an arrow and a dash. This is called the assignment arrow. And what I'm basically saying is that the code that I'm about to put behind the arrow, I want that to be referred to or named example _1. So I'm going to use that C function, so lowercase c, and I'm going to type in those numbers that I listed off. So we'll do -4, 0, 6, 1, -3, and -4. And then I'm going to press enter to run the code. And now it shows up in the environment pane. It's exactly what we want. So we can view it in a few ways. In the console, down here, I can just type the name of the object, example _1, and hit enter, and it will produce the list for me. If I want to see the list in the source pane, I can use the view function. So uppercase V, IEW, example. And usually when you start typing, a list of things that also start with the same characters you're typing with will show up. In this case, example _1 is at the top. It's highlighted, so I'm going to hit enter, and it will complete that for me. And then I'll hit enter again to run the code. And now we see that it shows up in our source pane. V1 or vector 1 is the name of the list, and we have all 6 of our numbers listed there. And just to remind everybody, when you type commands or import data or do anything in R and RStudio, everything is extremely case sensitive. So if you're ever having trouble running something, I always suggest that the first step you take when you troubleshoot is just make sure that the things that are supposed to be lowercase are lowercase and the things that are supposed to be uppercase are uppercase. You will be surprised at how many times you can track down that as the source of your problem. And I even say that as somebody with a ton of experience with R and RStudio. I still make that mistake all the time. And with some letters, it can be hard to see. V example is one character that I have a hard time telling the difference between lower and uppercase when I see it in a whole bunch of code. So to find the mean for the vector we created, we can use the mean function. MEAN will give us the mean, and then we want to find the mean of the numbers in example 1. And there we have it. The mean of the values in vector example _1 minus 0.666 infinity. It's just that simple. So you can use R and RStudio just like a basic calculator. In this sense, many of the functionalities don't differ too much from Excel. It's when you get into the more complex data analytics functions where R really takes the lead over Excel. But on the other hand, it's really important for you to know and understand how both of these software products can help you communicate information from data. So, as I said, we're usually going to import data into R. And how we would go about doing that, we can type it in with code, but in many cases we can just go to File, Import Data Set, and then depending on the format of the data set we want to import, we can select from our options here. Most frequently, you're probably either going to be working with Excel files or CSV files in this class. CSV files are classified as a type of text data, so you would want to import from text. Files in Excel format you would want to import from Excel. So let's go ahead and import a little bit of data from Excel. We can do that with this dialog box, and the first thing we want to do is find the file on our computer that we want to import. I want to import the admissions data set, so I'm going to go to Browse, and it takes me to my main working directory, which in my case is my documents, and I know this data set is going to be associated with this class and in my data folder. So this is admissions, Microsoft Excel, W worksheet. Above it is comma separated values. Comma separated values are CSV files. Again, you want to import those as text. I know that seems a little unintuitive because in most cases Excel will open CSV files for you. So just note and pay attention to the difference. So I'm going to double click admissions, and it pulls in a preview of the data so we can see the names of the different variables and the different types of values in them. Now we have some different options in terms of importing it. We can change the name of the data set. I'm going to leave it as admissions because that's intuitive. This is about whether or not students were admitted into a college. Admissions makes sense. The default sheet is the first sheet. If you're working with an Excel file that has multiple sheets, you can select which sheet you want to pull your data from and what range of values you want to pull in from that sheet, which can be helpful if you have a sheet that doesn't just have your data, but may also have some interpretation or some tests or just some other stuff off to the side. I also want the first row of the data set to be used to name the different columns. If I unselect this, what we see is that the columns are now numbered and our types of data look a little bit different. So we want our first rows as names. And then we can choose whether or not we want the data to show up in the data viewer, which is that source pane, when we import the data. So if I unclick that, we see the view admissions code disappeared. I'll click open data viewer again, and now we see view admissions is back. So I'm feeling pretty good about this situation, so I'm going to import this data by clicking import. And even though we imported the data using that dialog box, we still actually see the code that was used to import that data. So that's down here. Library read Excel, so it's using the read Excel package. It's creating an object called admissions, and admissions is associated with the Excel file that we're importing. And then I want to see the admissions data in the source pane when I'm finished. So that's really nice and awesome. So if you want to see a general overview of what you have in your data set, we can use the summary function. So I'm going to type in summary, and then we'll do admissions. And I'll hit enter to run the code. So here we see a summary of the 5 different variables in the admissions data set. So student, which is just an ID number for the application. Decision, SAT, female, and HSGPA or high school GPA. So decision and female are character variables, so we have the length or the number of observations listed, but we don't really have any other information. And we know the student variable is just an ID for the 1,230 applications that we have. So we're not seeing very much here. What if we want to just look at this average SAT score for the students? We can try mean SAT. Now that doesn't work. That doesn't work because while admissions is in our environment, we haven't added it to our working library. And by adding it to our working library, it basically tells our studio that all of the variable names are objects that we can directly call upon from our console. If I don't want to attach it to my working library, there's another way that I can get access to the SAT data. So we're going to try mean, and then I'm going to use the name of the object or the data set, which is admissions. Then I'm going to use the $sign, and now that I've used the $sign, a list of the individual variables in the data set have popped up. I'm interested in SAT. So I hit the down arrow twice, and now I'm going to hit enter to choose SAT, and I'll hit enter again to run the code. And here we can see that our mean SAT score is 1,197.348. Or we can use the attach function to attach this to our working library so that we can specifically call on the SAT function. So I'm going to type attach, and then admissions, hit enter, and you don't see anything now, but let's try using that mean SAT function again and see what happens. So now that I've attached the admissions data set to the working library, I can call directly on the names of the variables to generate results for me. So either of these approaches is completely fine. You'll discover as you work more and more in R, there are many ways to achieve the same ultimate result. So we can also choose a customized set of variables that we want to see the summary of. So in this case, we may not want to see the summary of the student ID numbers because they don't really tell us much. And it may be difficult to look at our character variables like decision and female. So maybe we only want to see our numerical variables, SAT and high school GPA. So we can specifically request this in our code. So we're going to look at the summary of admissions, but now we only want to see two of our numerical variables summarized. So I'm going to use a square bracket here, and now I'm going to use that C function. But first, because I'm only interested in those columns, I'm going to start with a comma. In general graph notation, we look at our rows and then our columns. In this case, rows aren't significant. We want to include all of them. We're only interested in defining specific columns. So we start with a comma, and then I use the combine function. I use regular brackets, and I'll type 3 and 5. So I want to see column 3 and I want to see column 5 in my output. I want to see summaries of those two variables. So I'll hit enter, and here I now have the summary of just SAT and high school GPA. And you can still see a little bit above there in the console window that the summary matches SAT, whether you look at the whole data set or just SAT and high school GPA. Now, if we're interested in a certain subset of rows, well, we can do that too. I'm going to press the up arrow on my keyboard once, and now we can see the line of code that I just ran. Now, if I just want to see maybe rows 1 through 100, I'll go before the comma, and I'll type 1, 100. So this says that I only want to see the summary of columns 3 and 5 for the first 100 rows of my data. And now I'm going to hit enter to run this. So now we see that the values are a little bit different because I'm only looking at the first 100 rows of data. The overall measures of central tendency are pretty similar, but now we're pulling from a smaller population. So that's all I wanted to show you right now to get you started, kind of get those wheels turning in your mind. When you're done with your data, you don't have to remove it, but you can remove it using the RM function. So I'm going to type RM, and then in brackets, admissions. I'm going to hit enter, and we'll see it disappear from the environment pane. Bye-bye, admissions data. I hope this information helps you get started and feeling comfortable in R. It can be challenging to learn how to use a language and software like R and RStudio. It's not much different than the challenge of learning another language like Spanish or German or Arabic. It's just more text-based. So hang in there and keep up the good work.